let's welcome Sahi of Sampatt.
Thank you, everybody. Am I audible at the back here? You are? Perfect. Thank you. Very welcome on this beautiful fall morning. The topic I'm presenting today is beyond A/B testing, how causal inference affects real-world marketing decisions. I am going to be spending a little time on going over some of the technical topics on how we, what techniques we use to parse out impact of a certain business initiative or quantifying what the value driven was using different causal inference techniques. But I'm not going to be spending too much time on that. I'll try to spin it with a business lens, more of that in my current role. I've been non-technical. Oh, thank you. I've been non-technical. I lead technical teams, and I collaborate a lot with leadership to help quantify how certain initiatives perform within the company, and I'll talk a little bit about all of those as well. Just help me out with my mic in case we need it. We have a clicker as well, so I can send a little.
Click away.
Perfect. Thank you.
Did you say you needed a mic?
Yeah, I think I'm good.
Okay. Cool. Thank you.
So here's the agenda for today. I'm going to start off with an introduction. I'll introduce myself and a little bit about 8451 in case you're not familiar with what that is. We'll go over a little bit about what causal inference is at a very high level, but again, nothing too technical. I'll address some of the real-world measurement challenges when we have different initiatives, like I mentioned, how do we quantify that impact back to leadership, and some of the challenges we face around that. We'll go over a few case studies. Again, I'll try to keep it. I've tried to keep it relevant to some of the use cases that I'm directly involved with 8451 and Kroger, but again, just also generic enough that you can extrapolate that to any other use cases. And then I want to spend some time on where we're headed from a future vision standpoint, and then we'll wrap up and have any Q&As at the very end. But more than welcome to ask any questions. Feel free to interrupt me at any time during the presentation. So with that, my name is Sahi Sampatt. As Professor Yichen basically introduced me earlier, I am the Director of Data Science at 8451. I lead teams that are support the Kroger marketing arm of 8451. Again, I'll go into a little bit what 8451 is and how that matters in the Kroger marketing sense. But I lead teams that design targeting and measurement systems for sending out marketing communications using rich first-party data that we have access to at Kroger. And as part of that, we have very robust scientific methods we use to parse out impact or use sciences to target relevant customers with relevant content. A little bit about my background. I've been born and raised in India. I came to UC for my master's. I'm a College of Business alum. I'm really grateful to be back here where it all started for me. It started actually in the old building, which I learned has been demolished for a garage now. But I love this new space as well. I've been residing in Cincinnati all the time that I've been in the US. I have a wife and a 5-year-old daughter at home. And I'm approaching a decade with 8451. So, yeah, been with this company for a while and love every day of it. Again, just a little bit of a background of what Kroger and 8451 does. Kroger is America's #1 grocery retailer in terms of its footprint, and I know it's a close competition. I don't know if any of you were following the merger news last year with Albertsons. So there's a close competition in terms of the brick and mortar stores with Albertsons, but I think Kroger is a little ahead in that, and is from a footprint standpoint is definitely number one in the US. We have records for 60 million households, which is like one in two households in the US. We shop at Kroger, and we have their shopping behavior data. And as you know, like with data at that scale, like there's like endless amount of use cases, and you can like how you can put that data to use. Within 8451, we are like the data science arm of Kroger. We are like wholly owned by Kroger. And the way we're divided within 8451 is we have a Kroger model and a commercial model. Kroger model aids with the supporting directly the Kroger enterprise, be it in the form of marketing or supply chain, shelf space, store layout, organization, anything that you can think of that's directly tied to helping Kroger make better decisions. And then the commercial arm is within the data monetization side of the business, where we partner a lot with CPG companies, Pepsi, Coca-Cola, P&G, P&Gs of the world. They're all our partners in this space, where the data we have about our customers at Kroger help all of those CPG clients to better understand their brand and how those customers are shopping in their brand as well. So you see how rich and useful having access to that data can be for CPG companies as well. I'll move us along to the next section, but before that, I'll just like give a brief executive summary of what the content for today is, just as a TLDR. So the topic I'm going to talk about today is going to be focused on marketing measurement, which is basically how do we parse out and quantify the impact of certain marketing communications and ways we communicate with our customers. I am on the personalization team within 8451, where we send out highly personalized communications and offers. If you've been in the Kroger app or have like interacted with Kroger emails before, you might have received targeted offers that are like specifically catered to your purchase behavior. So say like somebody might get a spend $50, get 5 off your next grocery trip coupon. Someone else, depending on if they have a higher spend threshold in the past whatever time frame we measure on, they can get a spend 100 and get 10 off. So highly personalized offers, and we want to meet the customer at the point that is most relevant to them. So so the context for the presentation today is like the measurement is very complex on a behind the scenes than it seems at the forefront, and I know having dealt with a lot of like leadership within the organization at Kroger, the key question is like, hey, how did my whatever campaign I was running perform, and how does that compare to like 100 other campaigns that I've ran in the past? And leadership, as we know, is like mostly concerned with like one number. They just need to know whether it performed like good, like $1 million in uplift or 10 million or whatever. But again, behind the scenes, there are like so much more to it that it's really hard to quantify and like put that into context. So it's also a matter of like helping contextualize some of these different analytical methodologies for the leadership, for the non-technical user, so that they can like make a more informed decision taking that into account. So I think the context today is the inconsistency, confusion, complexity that different methodologies create depending on different use cases, and how do we overcome that challenge? The challenge is basically, like I said, like we have randomized control trials, we have synthetic controls, we have dynamic controls, we have so many methodologies for causal inference. And again, I'll touch on some of these a little bit, which do generate that one number that leadership seeks, but again, depending on what methodology you use, there might be a heavy bias associated with it, so how do we quantify that? So that's like the nature of the challenge that we're talking about today. The vision that we want to progress toward, and I know there's the main theme of the symposium today is AI. So there's a heavy AI directed path of like what that future state and like what North Star state we aspire to get to looks like, and AI has a big role to play in that. But essentially, how do we replace that one number, and how do we contextualize that, like I said, and present leadership with a more digestible form of all of the numbers that they get today, by letting the AI take control of parsing out the different nuances and complexities of the different measurement types that come out. So that's kind of the holistic vision, and then that's reflected in like kind of the future state where we envision AI to be kind of the orchestration layer to help oversee like, hey, this campaign has used a randomized control for measuring, versus this campaign used Bayesian matching or whatever it may be. Taking that decision out of the hands of like an individual, no matter how qualified the individual may be, there's always going to be some degree of like bias or either a lack of context from a business standpoint that they might not have. So really, like we see that like the role of AI in the future is to help bridge that gap and like act as like that overseeing layer that looks at everything holistically and helps make a standardized decision for leadership. So that's kind of the overall gist of today's presentation. On this slide, I'm just gonna quickly give an overview of what causal inference is and means. Again, won't go into too much detail. I know we have Professor Vijan, who's an expert on this subject, so feel free to be honest with me in case I misspeak anywhere, but we'll welcome any questions along the way as well. But we're all familiar with like correlation is not always causation, and how many times we've heard that. But what really is causation? Like what is causing something? And that is like what the key question is. Like what if I want to know what causes a certain behavior? How do I parse that out? And that is where causal inference comes into the picture. So it's essentially the science of understanding what truly drives behavior. We have that visual there on the slide, which just simply tries to explain what that is. We have those two lines, the red and the gray, where we have a pre-period and we have a post-period. And then that dotted line is kind of we have a treatment for those groups, and we want to understand the impact of that treatment, what that is. Again, in a grocery sense, that can be the group in red outperform the group in gray, from a sales uplift standpoint, from a number of visits they've made, and any other metric that might be important. It can also mean like I'm adding a new capability to my website, or I'm adding a new feature in my application, and did that feature perform well? Was that a success? How do we quantify that? We typically have like two groups of households, typically called test and control, which look very similar to each other before any treatment was, they were exposed to any treatment. But post the treatment, if there was any deviation in their behavior, is what we quantify as uplift or that causal effect, to put it simply. So that's essentially what causal inference means. And there are many techniques that you can use, as I will go into some of those details here in a bit, on how we can like more precisely quantify that impact depending on what the business need is for that use case. When it comes to the gold standard for causal inference in the industry, there's nothing that comes close to randomized control trials, or RCTs, as I mentioned previously, where we essentially have the eligible population of like those who can receive certain treatment. Like I said, I'm more focused, my team's more focused on the marketing side of things, so I might want to send out a marketing campaign in the form of an email to like 1 million people who shop at Kroger, and I want to quantify the impact of sending out that email. One of the simplest and most effective forms is to have a randomized control trial type of experiment design, where we randomly hold out a small percentage of the overall population that's eligible for the treatment. It's typically like 5%, 10%, but also depends on like a lot of different factors and what that control holdout percentage is. And like I said, this is the gold standard in the industry, not just in the marketing space, but anywhere where precision of the number is of utmost importance. Think of it as any like medical clinical trials where somebody wants to test out the efficacy of a drug, a new drug in the market. The randomized control trial method is kind of the go-to method when precision is of utmost importance. There's a lot of challenges that come along with having randomized control trials, which I will cover in the next section, which is what leads us to like exploring alternative methods, which might be less precise. They might just give us a directional sense of like what the output was, or like what the success of a certain initiative was. And sometimes that's the way to go. It's inevitable that we have to use those techniques when randomized control trials aren't always possible. So in the next section, we'll talk a little bit about some of those challenges with the RCTs, and then also want to touch a little bit about from an interpretation standpoint to leadership. How do we contextualize like all of these different techniques as well? So, as I said, RCTs are powerful, but not always feasible to do. And there can be many reasons for that. The first one being that it impacts customer experience. I'll go back to my same example that I used earlier. I want to send an email out to 1 million Kroger customers. And I say I want to hold out 10% of customers from that population to be the control. So we are depriving those 10% households from receiving a communication which would have been relevant to them, but we're not sending them that because we want to precisely quantify like some numbers back to our stakeholders and our leadership. So that is definitely like one of the biggest considerations that we have to take into account when determining whether or not RCTs can or cannot be used. There are sometimes like sample sizes can be very small. I talked about 60 million households in Kroger. We have like 1 million households we want to send an email to. Those are pretty good sample sizes. But we sometimes also have to deal with just 100 customers. So there's a store that closed in Texas, and how do we communicate with those customers who shop regularly at that store to say, hey, it's closing down, there's another store within a 2-mile radius of this, make sure you start shopping there. Those are like real use cases. So in those instances, it's hard to have a holdout control because again, that impacts customer experience, that we don't communicate with those customers. But also it might introduce like biases and like may skew the results when we're operating at smaller sample sizes than we typically have. RCTs are also not possible for publicly marketed offerings. So if you like go into the store, you see like signages to say, hey, you sign up for free Boost, which Boost is like the equivalent of like a Amazon Prime. With Kroger, we have like free delivery, etc. So and take like $5 off your first grocery order when you sign up for Boost, or something along those lines where you have like signages within the store that's available to the public. And then when your stakeholders say, how did those signages perform, or was that like a successful campaign? It's hard to answer that question with RCTs because it's not hard, it's impossible to have an RCT for those kind of use cases. And then there can also be the problem of like some testing windows can be too short to parse out any meaningful impact. So again, if I were to communicate with you about an email, and I want to know if that shifted your behavior fundamentally as a excuse me, as a Kroger customer. And I would just want to measure over like a 2-week period after the email was sent. 2 weeks is too short of a time frame to make any conclusion or have enough data points under our belt to make a definitive conclusion on whether something worked or not. So that's also one of the main challenges. And then lastly, there can be multiple campaigns. Like I said, I want to send an email to 1 million people, but there might be 50 other campaigns that might be being run by other teams within 8451, within Kroger, that are also communicating to a subset of those customers or like have a large overlap with those customers. So as we have more campaigns coming into the equation, it tends to introduce noise and contamination when the objective of RCTs is to keep those two groups as pure as possible and not expose them to, and limit the exposure, I would say, to other initiatives that might cause some contamination or bias in the eventual results.
Does 8451 currently have a system where they mark, or different teams might mark whatever customers specifically into various groups, so different teams know like who's being tested by other teams, or is that sort of somewhat siloed?
So the question, in case it wasn't audible at the back, was does 8451 have like teams within 8451 have visibility into what other teams are doing from like communication standpoint? Was the question, and the answer is to a certain degree, yes. But again, there's like so many things going on in terms of like touch points we have with those customers. It's really hard for an individual, unless like there's like very sophisticated sciences that tap into that data to make some of those decisions. And then I'll talk a little bit without going too big of a tangent on this topic as well. But we do have a air traffic control kind of system which like tries to oversee within the program marketing space. Like these are like the 100 emails that are going out this week. How many of those customers are part of like 10 or 5 or whatever that upper limit threshold would be from a business standpoint, what feels acceptable to the business to have like a threshold on, and looks at that holistically. But again, that scope of that process is limited to everything that we do in the program marketing space only. And given how vast the organization is, there might be so many other teams that we even don't have visibility that might exist and like might be doing something similarly that we just don't have like visibility into. So that's like kind of the real reality of that. We always like try to bridge that gap as much as we possibly can, but it's definitely a hard problem to solve that at an enterprise at a scale at which we operate. So we talked about why RCTs are challenging to implement. Here are some non-experimental techniques that might be alternatives to RCTs for different types of use cases, and I'll go into those in like in the case study question in a section in a little bit as well. But we have matching, we have synthetic controls. We have the difference and differences approach. We have Bayesian hierarchical models. These are like just scratching the surface. There are like so many different techniques that can be used. And these are, like I said, all alternatives to when RCTs cannot be used. And with RCTs being the gold standard from like a precision standpoint, anytime we try to use any of these techniques, we are already going down in terms of like the precision we can expect from the results. So in the case of the matching, which is the first row, it can be heavily biased and positively biased in the favor of test households that receive the treatment. So when the leadership gets access to a result from a campaign that used matching for identifying the controls, they might see that that campaign performed so much better than a campaign that used RCTs, but to them, it just it's natural for leadership to try to do an apples to apples comparison and say, that campaign that used matching significantly outperformed the other campaign. But in reality, that might not be the case because, like I said, matching can introduce a heavy positive bias on the results of the test group. So again, you see how all of this like introduces so much complexity into the mix, and like when somebody at my level, where I am accountable to quantify the impact on the value coming out of certain marketing initiatives, how it's a huge challenge for me to quantify that back to my stakeholders and my leadership. Yes.
So can you elaborate a little bit more on why the positive bias? Is it because of the matching part was poorly done, or
Yeah.
what was the cause for the positive bias?
Yeah, no, that's a great question. The question was, Professor asked me to elaborate a little bit about why he thinks there would be a positive bias in the favor of the test households and the first matching methodology. So just to give you a quick overview of what matching is, essentially, like I said, this is an alternative to RCTs. So remember, RCTs hold out a random control group which don't get exposed to any treatment. But in this case, we're saying we don't want to hold out that 10% or whatever percentage is a random control. We want to make sure everyone who wants access to this treatment is able to get it. So typically what happens is like the households or the customers that do interact with that treatment or get exposed to that treatment are typically classified as test households. So again, say you guys log into your Kroger app, go into the coupon section, there's a coupon sitting there that's available to everybody. You clip that and then you use that in your next purchase. You'd be treated as a test household because you interacted with that coupon and you intentionally made a behavior because of that coupon. And then those who did not take the effort or did not care about going to the app or looking at the coupon or whatever, those are the households that are eligible to be control households that we can compare to. So inherently in this method, there's a self-selection bias that exists, where the test households are taking action, they show propensity to take a certain action that the control households don't, which might be fundamentally what's driving their behavior. There might be many reasons for that. There might be you might be very tech savvy, or you're big into deals, or want to find the best deal out there, trying to have as many discounts as you possibly can, without having anything to do with the nature of the offering itself, right? So there's like an inherent bias in that system. So when it comes to matching, like I said, the test households are always those who interact with the treatment. But when we try to match controls to them, we essentially try to match them on multiple parameters to say, like, how did their behavior look like in the period prior to the treatment? Try to match households as closely as we can to those who interacted with the offering. So it is definitely used in the industry, this matching process. But like I said, like there's so many different factors that might be coming into the picture when trying to find the ideal match for a control, which it's impossible to identify all of those. So that's kind of one of the biggest reasons. Like when it comes to a positive test bias towards the test group, there's academic research papers that show, even in companies like Meta, which are like so data rich, they know possibly everything about every individual, every aspect of their life. They published a white paper on this topic, and they identified like the bias in the favor of the test group is typically ranging from 2x to a 10x. So that's kind of the magnitude of the bias we're dealing with. So yeah, that was kind of a high level answer response to the question. Sorry, go ahead.
I have a very broad question. I've recently become very interested in synthetic controls, and I was just curious if you had a lot of success with synthetic controls. If you're able to find, define a lot of state free periods and all those kinds of things.
Yeah, the question was, have we had any success with using synthetic controls, which is the second row there. The answer is, again, yes, to a certain extent. There's no way we can completely say the output that we get out of that process is comparable to anything that we see with RCTs, which is definitely known. But there are multiple teams, multiple use cases within 8451 that use synthetic controls. Synthetic controls at a high level, for those who may not be familiar, again, non-experimental technique, which tries to look at those who did not interact with the treatment and then classifies them into like several groups of customers, like essentially doing like a mini segmentation of those who did not interact with the treatment, and then come up with like an average effect of like what that group combined did compared to the test households who did interact with the treatment. So again, going back to the question, yes, I think we definitely have use cases where synthetic controls are used. I think I would go as far as to say like a lot of our offsite tactics, which offsite being like we advertise with a lot of like third-party partners like Meta, Facebook, Instagram, Pinterest, Pandora, etc., where we just send those partners a list of customers that we want to target, and their decision algorithms decide who gets exposed to that ad, etc. So in those instances, like the more of a gray area there is from a visibility standpoint of like who actually got exposed versus like who we wanted to get exposed, I think some of those use cases heavily adopt synthetic controls within the company. Again, it's by no means perfect, but that's what the best in like a non-ideal situation kind of deal. Yeah. I'll try to move us along. I know we hopefully we're okay on time. But again, just this slide just summarizes like some of the challenges that arise from like all the different methodologies that we talked about on the previous slide. That anytime there's a need to measure something, this is like kind of a representation of like the decision tree that needs to be parsed through to decide which use cases require what kind of techniques, and then how to contextualize that back. So again, the gist of this slide is it's hard to compare numbers across the use cases that are using different techniques. And that puts data science teams under huge pressure within the company to explain and reconcile results across teams especially. And then that's also becomes a challenge to finance teams within not just our company, but I'm sure everywhere. Say, hey, well, how do we precisely quantify what our actual bottom line looks like from all of this? So, and there's also the question about having the right expertise on the teams, to have the right people who understand which techniques you want to apply to what use case. Make sure we set up the experimentation right. Again, like I said, leadership mainly cares about one number, so they don't care about all of those decisions that led up to generating that one number. I'll tell you an example. Within 8451, like I said, we have the Kroger arm and the commercial arm. Within the commercial arm, we have measurement teams that say deliver a measurement back to our clients at P&G or Coke or Pepsi or whatever. And a lot of times the feedback we get from our clients is, hey, why isn't my campaign performing as well as it is with when I run it with Target or Amazon, or I'm just using Target and Amazon as examples. I'm sure they have like very robust teams and measurement processes themselves, but you get the gist. There are like smaller players than Amazon and Target in the market that run similar campaigns. So just pick one of those, and they might say, why isn't the same campaign that I'm running with you guys performing significantly worse than what it is at other partners? And the answer to that is definitely not simple. There's like no one answer to that, but one of the answers to that can also be like, we put in so much rigor and like robustness into our measurement. We have experts in the industry on this topic, where our precision like negatively affects us in some cases, where what we are seeing, and I'm just like making up an example. This is not necessarily the case all the time, but I'm just saying like what we might be presenting as a fact back to our clients may in fact be the reality, as opposed to like what others are showing in terms of like the results that the higher results they're seeing with other partners. So I think all that to say is to just sum up, like when measurement is done wrong, everything that follows after that is also wrong. Like the downstream decision that it leads to can also be wrong in many cases. But yes, please, there's a question.
Yeah, for my instinct to me is if the population of these two companies like Amazon or like Causal may be different because the shopping style may be different population.
Yeah.
So they give you different results. That's my instant answer. Maybe not anything wrong with two data sets, just different population.
True, absolutely. Yeah, I think which is why I think there are so many different factors when it comes to giving an answer for that question. Like to Professor's point, that there's everything right with the methodology, everything right with the way both companies executed that campaign. It might just be like fundamentally there are different group of households that are within Amazon's ecosystem versus Meta's ecosystem versus Kroger's ecosystem that might have affected the result of the campaign, and that's absolutely an acceptable outcome of all this. But yeah, I think there's just like painting a different side of the picture of like a different other possibilities that might also have a role in like what's actually going on as well. So yeah, so totally acknowledge that point. Yeah, I do want to touch on a couple of case studies as well. I know we alluded to the first one here previously. So if I want to send an email marketing communication with the goal to measure incremental clicks to see how whether like either looking at the subject line preview in your inbox, you found the content to be pretty relevant that led you to click on the email, or once you like whatever that might be, like you might get a preview of the body of the email that you might find compelling. I want to send something with the goal to measure incremental clicks to that email. I think I have like 3 buckets there, like from a feasibility of randomization measurement approach and why that approach is the best fit for this purpose. I think this is one that's one of the easier ones where we can hold out customers for randomization. So simple RCT might be the best approach in this instance. It's a low operational risk. We can have a clean test control design, and amongst other methodologies, this is the one that's likely to produce the most precise measurement. Especially in the marketing sense, where it's not like a life and death situation where controls and RCTs are pretty commonplace. We run like thousands of campaigns within a year, and I think 90% of them use RCTs. But again, like some of the more time-sensitive or critical communications, we definitely give up the ability to have precise measurement back in the spirit of making sure every customer gets it and the reach is what we intended for it to be. But if you have like the second use case where you're running a national brand TV campaign with the goal to quantify brand or awareness effect, you're the head of marketing, you're running a huge Thanksgiving campaign on TV for Kroger, and you want to say, hey, can you quantify whether that campaign was a success or not? How do we do that? It's impossible to hold out random controls there. You don't know who gets exposed to that at any given point in time. Who might log in and watch that ad on that specific channel at that specific time. There's no way you can control that. So again, randomization is impossible in this case. That's when we have to go into suboptimal from a precision standpoint, suboptimal techniques, but still very powerful, like Bayesian hierarchical models, which essentially are scientific models that are like trained to, like again, in the absence of a true holdout control, try to find households that as closely mimic those households that would have otherwise received that treatment. And there are, again, we saw on the, like a few slides ago by there are challenges associated with different techniques depending on which one you use. This one specifically is very high on computation cost. So there are like huge cloud costs associated with running these kind of models. So again, like those are like all the things that factor into like the decision tree of which technique to apply and like which use case. The third one is basically you want to send some triggered communication with the goal to estimate incremental uplift among highly specific customer segments. So I'll give an example of like what something like this would look like. Say you go to Kroger.com, you start to build your basket for delivery the next day. You add like some oranges, cilantro in your cart, and then you just like forget that you forget about it, and you just abandon your cart at that point. And if I have like a use case within Kroger marketing to say, hey, those who abandoned their cart and it's been like 3 hours since they came back and interacted with the app, send them a targeted communication. In your case, you've like added, like I said, cilantros and oranges to your cart. Give them a coupon to say, hey, take 10% off your oranges and cilantro, and make sure you complete your checkout and build your cart. That is like a very specific subset of people that I'm sending that communication to. So again, like the sample size of people who might fit that criteria might be so small that it's just impossible to have like any kind of randomization associated with it to produce anything meaningful or precise. So in those instances, we can like adopt like some of the matching approaches we talked about earlier, where we try to match those customers as precisely as we possibly can on attributes like sales, units, visits, and other parameters to find lookalike households that might look like those households to quantify the impact. So that's another technique here. So this is just like a summary. This visualization is not meant for any like precision, just a rough representation. But if you look at the x-axis here, this is like as you go farther to the right, you go higher on the precision scale, and then the y-axis is the higher up you go. It adds more flexibility to you in terms of like scaling it to more people and making sure your customer experience isn't impacted. So if you like look at where RCTs sit, like they're on the far bottom right, as we would expect them to be. And then these are like some of the other techniques, like some of the time series or like pre-post based approaches are some of the least precise but offer the most flexibility kind of deal. So again, won't go into too much detail. Again, not meant for anything precise from a